You need to assign IP addresses to devices on your network, whether they're printers, computers, smart TVs, at your house. It could be any kind of Wi-Fi connected element or entity, whether it's a washer and dryer in your laundry room, whatever it is. There's a lot of IP addresses that need to be assigned, and you're either going to do that statically and manually and have to figure out how to configure every one of these different types of devices, or you're going to use DHCP, Dynamic Host Configuration Protocol. I'm going to tell you how to make DHCP work, not only in the local area, but in the wide area across routers. That's where the challenge becomes with DHCP. The reason I say the challenge with DHCP becomes when there's a router is because DHCP has always been a broadcast mechanism, a layer 2 broadcast protocol. So when a DHCP client boots up, it sends out a broadcast message. That's an all Fs Ethernet broadcast. I hope you can see that. The destination MAC address is all Fs, 6 bytes of the MAC address in the Ethernet frame header of where this broadcast is headed. We should know by now. If you don't, I'm here to tell you that a router will always and forever stop a layer 2 broadcast. All right? In its purest form, you need to understand that a layer 3 device, a router, forms a broadcast boundary on that layer 3 interface right there. Same is true for this layer 3 interface over here. Broadcasts will not go past that. Broadcasts will not go past that. This is where the term IP helper comes in. We need to configure on that interface where this broadcast is taking place. On this interface, we need to configure IP helper-address x.x.x.x, meaning some IP address. Now, what is that IP address? That is the IP address of this server interface. x.x.x.x, whatever it is, will equal that IP helper address right there. What the heck was that? Okay, here's where we're going to lab test DHCP and how to get it across a router. This is EVNG. I will link in the pop-out cards or the comments below how to add some nodes to an EVNG lab. The PC, I have the console right here. It is just a emulated type of a virtual PC that EVNG has built into it. And then I have the 2 routers here. Okay, router number 2 and router number 1. Okay, I have basic IP connectivity from this DHCP server to the LAN segment that it needs to assign IP addresses for. This would simulate that this is a simple server with a default gateway. Show IP route. We see that we have a default gateway. It's a simple subnet between the 2 routers. Show IP route connected 1.1.1.0/24. 1.1.1.0/24, and then on fast Ethernet 01 is 199.199.199.1. That's the subnet that we're going to be assigning IP addresses for. So we want to assign 199.199.199.0/24 addresses onto this broadcast domain over here. It's a very simple broadcast domain. It's just a PC directly connected to the router. There could be a switch there with a lot of different computers. There could be 50 or 100 computers out here. And this DHCP server is going to assign addresses out of that /24 block. All right. So here's that connectivity I mentioned. Okay, so the DHCP server can ping that LAN segment over there. Let me make this a little faster. and we see it's one hop away. So router number 1 can ping this LAN segment over here. You got to have the connectivity to send those DHCP requests back to the clients making the request. And so this is the pool, the DHCP pool, that this server will be getting, will be assigning those addresses out of. EVNG is very nice. We can capture, using Wireshark, the packets that arrive on this interface, fast Ethernet 0/1. Okay, some of these protocols, we can turn them off, not loop. Okay, that's a real-time display filter. We can turn that off. That we don't care about that. And so now we'll go to the virtual PC. If you type DHCP, it does a request. Now look at this. Here we go. Now the letter D indicates a discover message. Discover, discover, discover. You see that on the console here of the PC? And we see 3 discovers. Discover, discover, discover. It's very nice. This very slim, lightweight computer that you have in EVNG to test on. And so what we have is, we have those Ethernet layer 2 broadcasts. Look, destination broadcast, FF, 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 FF. That's the Ethernet destination broadcast for the DHCP request. I will also say and not CDP, because we have Cisco Discovery Protocol. So I'll remove that because we're only focused on DHCP. Another way of doing it would be, if you only wanted DHCP, you could do that. DHCP. I prefer it the other way, just to make sure that we don't miss something. I'll remove the things I know I don't want. Okay, so what I want to show you on the sniffer, just to make sure you're clear, is that the sniffer shows everything in the OSI or TCP IP reference model from layer 1, 2, 3, all the way up from data link to IP to transport to application, shows it in the opposite. So if you look at the layering, you have the data link layer, Ethernet, you have the IP layer, the network, which is the network layer, then you have the transport layer, user datagram protocol, then you have the application layer, DHCP discover message, okay? Here's the source, 68, and the destination port, 67, sometimes known as boot P, boot P client, boot P server, and so this is it. So you can see in the IP header that the addresses for the source is all zeros and the destinations is an all ones IP broadcast. And so what we need to do is figure out, is this getting to the DHCP server? And if it's not, then what are we going to do about that? Now here's how to configure a DHCP server in Cisco iOS. IP DHCP pool, you give your pool a name, you define your network, then you give it the mask that you want, then you give it a default router, and that's the default gateway of the router on the LAN segment over here. .1 is that address there. And that's a basic DHCP server configuration. You can also do an exclude address of the default gateway IP address, so it doesn't include that in the pool, just to make sure. Now, there's other options like DNS or host domain name and things like that, but we're not going to mess around with that right now. We're just going to put in a basic configuration. Okay, there we go. Show IP DHCP server is a way of looking at, you can look at the statistics to see, have you received any discover messages or release messages or anything like that? Have you sent any offers or replies or anything like that? Okay. You can also look at the bindings of addresses that have been assigned. You can look at the pool as it's been configured currently. So there's your pool name. Here's your address range, 1 through .254. So you can see that it excludes the broadcast address. And so we're ready to go to assign IP addresses using this Cisco iOS DHCP server. I'll turn on a sniffer on Fast Ethernet 00 of the DHCP server so we can verify when addresses come in to the server. Okay, so there's the sniffer at the DHCP server. Here's the sniffer on the LAN segment. And we can verify one more time. When we send a DHCP request, they hit the interface of the default router right there, but they don't quite get over to the DHCP server yet. This is where IP Helper comes in. When we look at the interface of the LAN segment facing the PC, we go to that interface, which is where the broadcast is arriving from the PC. IP Helper-Address, This would be the IP address of the DHCP server. Type that in, save the config. Now, when we look back at our sniffers and we do our DHCP request again, now we see, look at this, discover, offer, request, ACK, and we get assigned an IP address. So there's your discover, offer, request, ACK. So if we go back over here and we look at the discover, we see that we got a discover on the LAN segment. We go over to the DHCP server and we see that it also received a discover. The difference is the discover on the LAN segment is a broadcast, but the discover as it arrives at the DHCP server is a unicast, and the source is 199.199.199.1. It's the actual router interface of the LAN segment reformulated as a unicast. Okay, so if you look at the discover message on the LAN segment, you see if you open it up, open up that application layer and look down in here, you will see that it has the MAC address of the computer, and then if you look at it as it arrives at the server, that client MAC address is still there. So it knows how to bind that client's MAC address with an IP address assignment. Also, as it arrives at the DHCP server, it has the relay agent IP address put in there where it came from. So it knows how to send that traffic back towards the client that's requesting it. And if you see, later we'll look at the offer, okay? I'm going to show you one more thing. I just want to emphasize once again, we already talked earlier about the fact that a router layer 3 interface is where a broadcast stops. Well, if the router is stopping DHCP from coming across in its natural behavior, then we need something that will help that DHCP get to where it's going. Okay? And that's the whole concept of IP helper. It's helping. It's helping a protocol that is being broken by the fact that the router won't forward it. All right? So you're helping this UDP message that we saw coming from port 67 going to port 68. The application sitting on top of UDP is DHCP, and it's a layer 2 broadcast, and so we need to help that. So what you're doing with the IP helper statement is you're taking a broadcast message and you're you're reformulating it. The router is reformulating the header into a unicast. And so then it can flow across a network in a unicast fashion, okay? And so that's exactly what we're seeing here. We're seeing that the previous discover message, which is the kickoff of the DORA process is the discover. That discover message is, in fact, an Ethernet broadcast and an IP broadcast as well. Well, you can see that as it arrives at the DHCP server, it is no longer a broadcast, it is a unicast message going to the destination 1.1.1.1, which is definitely the IP address that we configured on the helper statement. That's what is being used as the destination address as this discover gets reformulated into a unicast. I'm going to show you some instrumentation that's built in to a lot of DHCP servers. This is pretty interesting, and if you might wonder what the heck this is if you look at it. The discover message that as it arrives at the DHCP server is not followed immediately by an offer. What is it followed by? It's followed by a ping request. A ping request for what? Well, the source is the actual DHCP server, 1.1.1.1. The destination is 199.199.199.2. So what's going on here is a lot of DHCP servers have this built into it. It's a check. It's a sanity check to make sure that it's not about to assign out an address duplicately, okay, or to something that already has an address configured on it otherwise, maybe manually. And so the discover comes in, but then we see a ping go out to 199.199.199.2. Ping. Well, do we see a reply? Let's look. We see a ping. Then the client sends another DHCP discover message because the server hasn't given a response yet. The server sends out another ping. And see that echo request ping? Well, when the server does not get a response back, it then feels that it is safe to send out the offer. There you go. There's the offer. Okay, coming from the server, from 1.1.1.1, going to the DHCP relay agent, which is in fact the interface on the router facing the PC, facing the LAN. And let's look at that offer. There's the offer. We are offering the IP address. There's the lease time. There's the mask. And there's the relay agent. Oh, and here's the client IP address, 199.199.199.2. So we see that we are offering the address that we as the DHCP server now feel safe to assign because we did not get a response back from our pings. I'll throw this in there real quick. Very interesting. I've worked at a location before where we found that there was an IP conflict. Well, we found later that the IP addresses, as they were given to some computers, or maybe they were statically assigned on computers, also had a firewall that would not allow the PC to respond to pings. And so what happened was when the DHCP server went to ping a certain IP address and it was firewalled on the PC, the PC would not respond to the ping. Therefore, the server thought it was okay to assign the address, and it went ahead and duplicately assigned an IP address because the ping was never replied to. So this doesn't always work, but it is a nice little thing built into some DHCP servers to avoid a duplicate IP assignment. And so to show the completed process, we have the DORA discover, offer, request, ACK, which is the complete dialog of a successful DHCP transaction, and it is received at the server as well. Discover, offer, request, ACK. Okay, and so the way that looks is the discover, the offer, the request, and then the ACK. All right, and that's the complete DHCP process. Once those 4 transactions have taken place, then DHCP is in a steady state, and it just maintains its IP address for its lease time. And so we can look in the DHCP server, show IP DHCP server, statistics. We have received some discover messages, a request. We've given the offer, and also an ACK has been sent. And we can look at the bindings. We see that 199.199.199.2 is assigned. Here's the MAC address. And we can look at the pool. It even tells us what the next index number is. So the next index is going to be 3. That's the one waiting to be assigned. And over here on the computer, we can type show, tells us what our our IP address is, our gateway, and we can ping the DHCP server now from the PC 2 hops away. I'm going to link in the cards or the comments below something that I talked about recently in another video, and that is accomplishing inter-vlan routing, or really just accomplishing routing on a multi-layer device. Do you route on a physical interface using sub-interfaces and put IP addresses on those sub-interfaces, or do you route on what are known as switch virtual interfaces, SVIs, otherwise known as interface VLAN, and you put IP addresses on the interface VLAN? The only reason I bring this up is whichever you choose is where you put the IP helper-address command. The IP helper-address command is where those broadcasts are received on that layer 3 interface. So whether you choose to do layer 3 routing on G00.1 and you put an IP address underneath that, that's where you're going to put the IP helper-address, or whether you choose to, I'll draw a box around it. You'll see why in my other video that I do, just to indicate it's a multi-layer device and that you're bridging across the forwarding plane and bringing the layer 3 into an SVI inside the routing function in the multi-layer device, thus using SVIs, interface VLAN, and that's where you put the IP address. That's where you're going to put the IP helper. So however you're routing this VLAN, whether it's on the physical port with sub-interfaces or whether it's in the logical router in your multi-layer device using SVIs, it's your choice, but whichever one you use, that's where you put that IP helper-address statement. Okay, so one final test, DHCP-X on this little PC, is how to release a DHCP lease. And so now we see that we have no IP address. We have released our IP address. That's signaled to the DHCP pool to free up that lease. It is now gone. There is no binding, and our pool shows that the next index is back to 1. It's going to skip 1 because it won't hand out the reserved address or the default gateway. So the point is that we have released this, and we're going to do one more test. Oh my gosh. What if we have to do IP helper to get a DHCP address through 10 routers? Not to fear. This is not a problem. Because remember, the challenge is really fixing this broken DHCP broadcast. That broadcast comes in to that router interface, and that IP helper reformulates that IP packet as a unicast. Ucast. A unicast can flow across an IP network end to end. 99% of all traffic going across our networks today is unicast IP. All the internet traffic, all your Netflix movies you watch, all the voice over IP, all the file transfers, all your social media, all your gaming is all unicast traffic. So the global internet is by and large, is a unicast IP routed network. And so no big deal. This is a unicast IP cloud, otherwise known as a typical IP network. Once that IP helper reformulates that broadcast and sends it as a unicast, we're good to go. The discover will make it there. The offer will make it all the way back to that router interface, and we will see that everything is just fine. I'll link another video I did on traffic types. That might also solidify a little bit about different types of traffic and IP networks. And so let's get back over here to the lab. Okay, let's do our DHCP request. There we go. Discover offer request ACK. Beautiful. 199, 199, 199.2. Let's look at our pool. Our next index is 3, which means we have a binding for 2. Can the DHCP server ping that all the way across the network? It can. Let's look at a trace. Look at that. 12 hops end to end across that network. We are good to go. Hey, this has been fun. I hope you're getting something out of these videos. I hope you have a greater understanding of how to do IP helper and how to get that DHCP layer 2 broadcast reformulated into that unicast using that IP helper-address command sent over to that DHCP server. You also have a little tricks here on how to use Cisco iOS as a temporary DHCP server. It comes in very handy when you need to test a DHCP function somewhere in your network, or just get to understand it a little better for your own knowledge. All right, subscribe if you haven't already. Share these videos with somebody else that you think could benefit from it, and I look forward to the next one.